Look, we've all been there, right? You're staring at an absolute nightmare of a code base. You've just copy-pasted the exact same block of code into what, 5 different classes? Your file is getting endlessly long, and inevitably, when a bug pops up, you have to hunt it down in every single one of those 5 places. It's a massive waste of time. Welcome to this explainer on one of object-oriented programming's absolute most powerful weapons. I'm your host, and today we are going to master the principle that will literally save you from ever rewriting code again: inheritance. Okay, here's the game plan for today's explainer. 1. Stop code repetition. 2. Super and subclasses. 3. Customizing methods. And 4, we're going to wrap up by tackling some real exam question solutions to actually prove your knowledge. Let's do this. All right, let's dive into part 1, stop code repetition. We're talking about the DRY principle. Just imagine that messy, totally exhausting approach of building separate classes for a sports car, an electric car, and an SUV, and having to manually type out speed and color for every single one. It is grueling. The DRY approach, which stands for don't repeat yourself, completely fixes this. We write speed and color exactly once in a main car class. Inheritance acts as the ultimate hack here. It uses this main class as a template. So every new car automatically gets those traits. You literally write it once and reuse it everywhere. Moving right along to part 2, super and subclasses. This is where we build the hierarchy. So inheritance, or kalitum, as you'll often see it on your Turkish exams, is basically a principle where a subclass receives the attributes and methods of a superclass to maximize code reusability. Honestly, think of it exactly like real-world genetics. Just like you inherit, say, your eye color or your height from your parents, software classes inherit traits. The superclass acts as the parent, setting the baseline rules, and the subclass is the child born with those rules already hardwired in place. Now, pay attention here, because this is absolutely crucial. This is the golden rule of inheritance, and I guarantee professors love to trap students with this on exams. For inheritance to work, there absolutely must be and is a relationship. A dog is an animal. A sports car is a car. Simple, right? But never, ever confuse this with a has-a relationship. A car is not a wheel. A car has a wheel. That isn't inheritance at all. That is called composition. Knowing the difference right there, that separates the amateurs from the pros. Okay, part 3, customizing methods. This is all about evolution, not just blind copying. When you're in the trenches coding, especially in Python, you're going to use the super function. I want you to think of it kind of like an elevator. It travels up to the parent class, grabs all that foundational code, and brings it right back down to your subclass. But the real magic happens with method overwriting, or assure you'll laundromat. A subclass can actually take a parent's behavior and completely rewrite it to fit its own specific needs. This is your very first step into the wild world of polymorphism. Let's think about this for a second. If you ask a totally generic animal class to make a sound, it's just going to return a boring generic response like makes a sound or ses çıkarıyor. But a cat class, even though it inherits from animal, it overrides that specific method. When you ask the cat to make a sound, it says meow. The child class didn't just copy the parent, it took the parent's behavior and evolved it. And finally, part 4, exam questions solutions. It is time to test your knowledge. I want you to really think about these before I give the answer. All right, here is a classic trap straight from a university OOP exam. What exactly is the relationship between the araba, or car class, and the tekerlek, the wheel class? Think back to our golden rule. What do you think? Boom! The answer is composition. Why? Well, because a car is not a wheel. The is-a test completely fails here. A car has a wheel. Holding another class as an object inside your class is composition. Definitely not inheritance. If you caught that, you just earned your first exam point. Way to go! Okay, question 2. Why does the kush, the bird class, inherit from haywan, the animal class, using the super function? What are we actually losing if we don't use it? Take a second. Reusability. That is the absolute magic word. It directly solves that messy code nightmare we talked about at the very beginning. The super function allows the bird class to instantly copy all the rules and traits from the animal class in just a single line of code. You literally never have to write that foundational code from scratch again. All right, final technical challenge for you. The animal superclass outputs ses çıkarıyor,
basically makes a sound. But the kepek, the dog subclass, changes this to hav, or bark. What is the specific OOP terminology for this action?
It's method overriding, or aşırı yönlendirme. The subclass didn't just blindly accept the ability passed down by the parent, it completely redefined it for its own specific needs. And let me tell you, mastering this is what gives our programs such incredibly flexible architecture. So, today we completely decoded the mechanics of inheritance. We covered the ISA rule, the supercondo elevator, and method overriding. You are now officially immune to the trap of repetitive code. So thinking about your next big software project, how are you going to use this powerful hierarchy to make your codebase more elegant, more reusable, and totally bug-free? Thanks so much for joining this explainer. Keep your classes clean and seriously, keep your code dry.